A bpsk constellation is corrupted by noise having PDF as given in the figure below. So this is the bpsk constellation itself, and this is the PDF of the noise. The received signal is R equals to SI plus W, where SI is equals to E plus or minus 1 for I equals 1, 2. What is the average probability of error, assuming that the two symbols are equally likely? Okay, so first of all, we proceed to find the value of A in this case, and we notice that this is a PDF, so the area under a PDF must always be equals to 1. So we solve for A by finding that area. So 4 into 2A over 3 plus 2 into A over 3 gives us 10A over 3, and that must be equal to 1, which means A must then be equal to 3 over 10. Now, the probability of error, when we try to crystallize this together, we know that we are trying to transmit a minus 1 or a plus 1. So the probability of error must then arise from receiving a 1 when receiving a plus 1 when you transmitted a minus 1, or receiving a minus 1 when you transmitted a plus 1. Summing the two together, that should give us the probability of error. So probability of error P sub E must be equal to the probability of receiving minus 1 given that plus 1 was transmitted, multiplied by probability of plus 1 itself, plus the probability of receiving a plus 1 when a minus 1 was transmitted, multiplied by the probability of minus 1. This relation is known as Bayes' rule. It's the Bayes' rule for conditional probabilities, and that sum would give us the probability of error. We know that the two bits are equally, the two signals are have equal probability of occurrence. So probability of minus 1 should be equal to the probability of plus 1 should be equal to 0.5. That means 1 over 2. Okay, and in order for us to find the conditional probability of receiving a minus 1 given that a plus 1 was transmitted, we have to look for that in our PDF. So given that a plus 1 is transmitted, then you end up receiving a minus 1. What portion of the PDF does that occupy? So the PDF stretches 4 units on the x-axis, and the maximum amplitude there on the PDF is 3 over 10. So if you receive a plus 1, this is the area you are interested. This is where the error is found. It's receiving a minus 1 when plus 1 was transmitted. We already know that the height at this point is 2 over 10. And so we have 2 over 10. So the probability of error in this case, the probability of a plus 1 given that minus 1, or the probability of minus 1 given that plus 1 was transmitted, would be, the two of them are actually equal. The two of them must be equal, so you have 2 over 10. So the probability of error will be this summation over here. So you're going to have 2 over 10 in both cases, multiplied by 0.5, since the two of them are equal, multiplied by 2, and that gives you 2 over 10. So this is the probability of error that you're interested in.